Right, Math 175, Calculus 1, the first midterm, I'm going to go over the problems. So the first problem had three parts, calculating some limits. So in part A, we're taking the limit as x goes to infinity of a rational function, 28x cubed minus 7x squared plus 90x minus 1 divided by 18x cubed minus 13x plus 3. And you see that in this rational function, the numerator and the denominator have the same degree. They both have degree 3. And in that case, the limit as x goes to infinity is always the ratio of the leading coefficient. So the coefficient of x cubed is 28. The coefficient in the denominator of x cubed is 18. So that's the limit, which is 14 over 9. And if you want to understand why that's the case, if you take 28x cubed minus 7x squared plus 90 over x minus 1, you could always factor out x cubed from the numerator, and you get an expression that looks like this: 28 minus 7x squared over x cubed plus 90x over x cubed minus 1 over x cubed. And similarly, if you, from the denominator, 18x cubed minus 13x plus 3, if you factor out x cubed, you get 18 minus 13x over x cubed plus 3 over x cubed. And what you see is the x cubes cancel. So this is, in the numerator, 28 minus, this is x squared over x cubed is 1 over x, 7 over x. X over x cubed is 1 over x squared plus 90 over x squared minus 1 over x cubed. And in the denominator, you have 18 minus 13 over x squared plus 3 over x cubed. And you can see that as x goes to infinity, these terms all go to 0. So the limit is simply 28 over 18, or 14 over 9, as I say. So that's part A. In part B, we're taking the limit as t goes to 6 of t minus 6 over t squared minus 36. And you can't just plug in t equals 6. You get 0 over 0, which isn't defined. But limit, this is as t goes to 6. T squared minus 36 factors into t plus 36, t plus 6, and t minus 6. And the t minus 6 in the numerator and denominator cancel. So this is the limit. When they cancel, you get 1 over t plus 6. And as t goes to 6, t plus 6 goes to 12. So this limit is 1 over 12. In part C, we have the limit as theta goes to 0 of sine 2 theta over theta. And you remember the basic trigonometric limit, the limit as theta goes to 0, sine theta over theta is 1. But here we don't have sine theta over theta, we have sine 2 theta over theta. But of course, I can always write 1 over theta as 2 over 2 theta. I'm just multiplying top and bottom by 2. So this is 2 times the limit, let me put this that way, of, take the 2 outside the limit sign, sine 2 theta over 2 theta as theta goes to 0, So I have the same variable on the top and the bottom. This limit is 1. So this is 2 times 1, or 2. And that's the answer. That's problem 1. Problem 2, as I said before the exam, would be a series of differentiation exercises. I will give you a list of functions, and you have to differentiate them. So the first is a polynomial. F of x is 2x to the 5th minus x to the 4th minus 3x plus 10. So this is the most straightforward differentiation, derivative. The derivative of x to the 5th is 5x to the 4th. And 2 times 5 is 10x to the 4th. Derivative of x to the 4th is 4x cubed. The derivative of x is 1, so derivative of minus 3x is minus 3. And that's the answer. For part B, we have a trigonometric function. G of theta is sine theta plus cosine theta. And you know, or you're supposed to know, certainly, a derivative of the sine is the cosine. Derivative of the cosine is minus the sine. Part C, we have the function h of x equals e to the x square root of x. Or if you like, e to the x, x to the 1/2 power. So this is a product, so use the product rule. H prime of x is the derivative of e to the x, which is e to the x times x to the 1/2, plus e to the x times the derivative of x to the 1/2, which is 1/2 x to the minus 1/2. So you can simplify this if you like. This is e to the x square root of x plus e to the x over 2 times the square root of x. Or even if you wanted to put this over a common denominator of 2 root x, and you factor out an e to the x, you get, multiply this by 2 root x, you get 2x plus 1. So 2x plus 1 e to 2x plus 1. Part D is the function m of x equals 5x minus 9 over 2x minus 3. So this is a quotient of two functions. So you use the quotient rule. M prime of x is what? You take the denominator squared, 2x minus 3 squared, and then in the numerator, you have the derivative of the numerator. The derivative of 5x minus 9 is 5 times the denominator, minus the numerator, times the derivative of the denominator. The derivative of the denominator is 2. Derivative of 2x minus 3 is 2. So if you expand this, you get over 2x minus 3 squared, 10x minus 15 minus 10x plus 18. And the 10x's cancel, and 18 minus 15 is 3. So this is just 3 over 2x minus 3 squared. Okay. Part E is again a quotient. We have the function r of x equals tangent x over x squared. So r prime of x, you square the denominator, r squared squared, and in the numerator, you get the derivative of the numerator. Derivative of the tangent is secant squared x times the denominator, minus the numerator times the derivative of the denominator, which is 2x. So that's what you get. And in the denominator, you have x to the fourth. So if you wanted to divide out by x, perfectly okay. You will have x cubed in the denominator, and in the numerator, x secant squared x minus 2 tangent x. But it's okay to leave it like this. And finally, part F, you have a function s of x equal to e to the minus x cubed. So this is just the chain rule. It's the derivative of minus x cubed, which is minus 3x squared, times e to the minus x cubed. And that's part F. Problem 3 is to compute a second derivative. F of x is x cubed e to the x. So the first derivative by the product rule is 3x squared e to the x plus x cubed e to the x. And if you want, you could write this. You can simplify this in various ways. Let's just factor out an e to the x. E to the x times 3x squared plus x cubed. So then the second derivative is e to the x 3x squared plus x cubed plus e to the x times the derivative of 3x squared plus x cubed, which is 6x plus 3x squared. And if you factor out an e to the x, and you collect what terms we have an x cubed, 3x squared plus 3x squared is 6x squared, and plus 6x. So you can leave it like that, or if you choose to factor out an x, that's also okay. E to the x squared plus 6x plus 6. But any of these forms is okay. That's perfectly good. Okay, that's problem 3. In problem 4, we have the curve. It's a cubic curve. Y equals x cubed minus 6x squared plus 11. So for this curve, y prime, or dy dx, is 3x squared minus 12x. So that's the slope of the tangent to the curve at any point x. And at the point x equal 2, the slope of the tangent, dy dx, let me just write this at x equal 2, is equal to 3 times 2 squared minus 12 times 2. That's equal to 3 times 4 is 12 minus 24. That's minus 12. So the slope of the tangent line at x equal 2 is minus 12. And at x equal 2, what is y equal to? This is y. At x equal 2, y is 2 cubed minus 6 times 2 squared plus 11. That's 8. Let's see, 4 times 6 is 24, minus 24 plus 11. That's minus 24 plus 19. That's minus 5. So the tangent line, remember the tangent of the line through a point y is equal to the slope m times x minus x naught at the point, plus the value of y at that point. So y is equal to the slope. What is the slope? Minus 12, x minus 2, and when x is equal to 2, this is minus 5. So we get y is equal to minus 12x plus 24 minus 5 is minus 12x plus 19. Minus 12x plus 19. Legible. Okay. That's problem number 4. Problem number 5 was to find dy dx for the curve x plus y equals cosine y. So we differentiate with respect to x. The derivative with respect to x of x plus y is the derivative of x with respect to x plus the derivative of y with respect to x. The derivative of x with respect to x is 1 plus dy dx. The problem is to find dy dx by implicit differentiation. So this is the left-hand side. The right-hand side is cosine y. If you differentiate cosine y with respect to x, that's the derivative of cosine y with respect to y, dy dx. The derivative of cosine y with respect to y is minus sine y times dy dx. So when we differentiate this equation with respect to x, what we get on the left is 1 plus dy dx. And what we get on the right is minus sine y dy dx. So if you just rearrange this, bring this over to the other side, you get 1 plus sine y dy dx equals minus 1, just rearranging this equation, which means dy dx is minus 1 over 1 plus the sine of y. That's problem 5. Problem 6 is to use the definition of the derivative. What is the derivative of a function at x? It's the limit as h goes to 0 of f of x plus h minus f of x over h. And we want to use the definition of the derivative to compute the derivative of f of x equals x squared minus x. Now we know that for this, the answer, of course, is f prime of x is 2x minus 1. But I'm not asking you to just differentiate x squared minus x and write down this formula. I'm using you to actually prove, using the definition of the derivative, that this is correct. So I have to actually calculate this expression. So f of x plus h, what is that? That's x plus h squared minus x plus h. So that means I take f of x plus h minus f of x. That's this expression. Let me write it down carefully. F of x plus h is x plus h squared minus x plus h minus f of x, which is x squared minus x. So f of x plus h minus f of x is equal to this. What is x plus h squared? That's x squared plus 2xh plus h squared minus x minus h minus this minus x squared plus x. So the x squareds cancel and the x's cancel. So this is equal to 2xh plus h squared minus h. And I'm taking this and I'm dividing it by h. So I can cancel an h, I can factor an h out of the numerator and divide by h. What I get is 2x plus h minus 1. Factor out an h and cancel. So the limit, as h goes to 0, of f of x plus h minus f of x over h is the limit, as h goes to 0, of 2x plus h minus 1. As h goes to 0, 2x is 2x. As h goes to 0, h disappears, goes to 0, minus 1. And that's the answer. Okay. And the last problem is problem number 7. We have an object that is falling down under the force of gravity, and the position at time t, s of t, so the position is s, t is time. At time t, the height above the ground is minus 16t squared plus v naught, the initial velocity of t, plus s naught, the initial height, right? So it's like at some height, s naught above the ground, you drop this particle, and the initial velocity is v0, and it falls and hits the ground. Or it might be, if you want to look at this as a function of time, you can think of it like this also. So here's time, and here's the position s of t. And when time t equals 0, you're at height s naught. And you throw this object straight up or straight down, depending on whether the velocity is positive or negative. Let's say you throw it up. So as time increases, it goes up, then it comes down, and then it hits the ground at some point. So as a function of time, this is a quadratic with a negative leading coefficient. So the trajectory is a parabola. It's parabolic, opening downwards. It always looks like that. What's the average velocity on the interval from 0 to 3? Well, at time 0, s of 0, oh, I'm sorry. So this is the general formula. And in this particular problem, we're told that the stone is dropped from the top of a building 400 feet tall. So S naught, the initial height, is 400. The units are feet. And the initial velocity is 0 feet per second, or whatever the units might be for time. So the position at time t is given by minus 16t squared. V naught is 0, so that term is 0, plus 400. This is the equation of motion of our particle. It starts off 400 feet above the ground, in this case, and it drops. There's no initial velocity throwing it up or down. It just drops under the force of gravity. So at time 0, S of 0 is 400. 3 seconds later, the position at time 3 is minus 16, 3 squared plus 400. Let's see, this is 9. 9 times 16, 144. What is that equal to? 400 minus 144 is 256. So that's the distance traveled in 3 seconds. So the average velocity on an interval of time is how much the particle is moved in that interval of time divided by the amount of time. So the average velocity on 0, 3, from time t equals 0 to t equals 3, is equal to s of 3 minus s of 0 divided by the time interval 3. So s of 3 is 400 minus 144, 256, minus 400 over 3. This is 144 minus 144 over 3. So this is minus, what's 3 into 144? 3 into 14 goes 4, 48, I believe. So minus 48 feet per second is the average velocity over this interval of time. Now, the instantaneous velocity is v of t. It's the derivative of the position s of t. It's s prime of t. S of t is minus 16t squared plus 400. So the derivative is minus 16 times 2 is minus 32 t feet per second. So the velocity, the instantaneous velocity at time 3 is minus 32 times 3, or minus 96 feet per second. That's the instantaneous velocity. When does the stone hit the ground? Stone hits ground when s of t is equal to 0, when the height above the ground is 0. That means the stone has hit the ground. So we have to solve the equation. What is s of t? Minus 16t squared plus 400. You have to find t where minus 16t squared equals plus 400 is 0. So 16t squared equals 400, which means t squared is 400 over 16, which I believe is 25. And if t squared is 25, t is equal to 5 seconds. Square root of 25 is 5. So it takes 5 seconds for this stone to hit the ground. And what is its terminal velocity? The velocity at 5 seconds is v of 5. V is minus 32t, so we get minus 32 times 5 is minus 160 feet per second. So this is the terminal velocity of the particle. And that, lo and behold, is the entire exam. So we're done.